A very good morning, good afternoon, or indeed good evening, wherever in the world you happen to be, and welcome to the All-Electric Revolution. This webinar forms part of Riviera's Maritime Hybrid Electric and Fuel Cells Webinar Week, which runs this week and will be 45 minutes in length. The webinar is brought to you in association with our premier partner, Navtech Naval Technologies, Inc. Now, ladies and gentlemen, before we get underway, I'm going to share with you key information that will help you get the most out of today's webinar. First of all, please be assured that we will send you the recording. Please do submit your questions at any time because we will do Q&A throughout the webinar. And any questions that we don't get to, we will come back to you in writing within a week of the webinar. So there's every reason to fire your questions through the messenger. Please do stay tuned into the end so you don't miss out. I guarantee that over the next 45 minutes, you will receive original, exclusive, and insightful information that will really benefit your business. So please stay tuned. And finally, please complete the exit survey, and in turn, we'll send you the presentations. Now, ladies and gentlemen, it's time I introduced your hosts. Your hosts are Riviera Maritime Media. They are a maritime and offshore information specialist active in 4 areas: news, events, jobs, and data. Should you wish to know more, please visit the dedicated website www.rivieramm.com. So about time I introduce myself. I'm Edwin Lampert. I'm Head of Content at Riviera Maritime Media, and I'll be moderating proceedings today. So look at the agenda. We'll be covering charging considerations and innovations. We'll look at creating extra redundancy. We'll look at what it takes to gain a return on investment. We'll consider the question of all electric ready and converting hybrid to full electric. We'll look at the green agenda and implications post-COVID-19. And there'll be a case study on operational challenges and the achievements of live all-electric ferries, so plenty ahead. Let's look at the running order, or in other words, how it's going to go. Presentations will be run consecutively and followed by open discussion. As you know, please submit your questions at any time because we will do Q&A throughout the webinar. At the end of the webinar, we'll share key takeaways and conclusions, and we'll also preview what's next. At this juncture, ladies and gentlemen, let me introduce our panel. I'm delighted that we have Cecily Larson. Cecily is, of course, Project Manager, Renewable Energy with Ellen E. Ferry Aero Commune. We have Ferhat Akuna. He is General Manager with Navtech Naval Technologies. A warm welcome, Ferhat. And completing our panel, I'm delighted we have Halvard Hauso, who of course is Chief Commercial Officer with Corvus Energy. During the course of the webinar, we'll take time for a poll, so please do fire in your questions via the messenger. And speaking of questions, don't forget, submit your questions via the webinar messenger and we'll get to as many of them as we possibly can. Well, more than enough from me. What I'd like to do now is get underway. And Cecily, you're first up. So as when you're ready, Cecily, the floor, as they say, is yours.
Thank you, Edwin. Today I will be presenting the eFerry project, and in doing so I will be addressing some of the discussion points that you highlighted earlier. Specifically, I will be addressing charging considerations and innovation, and creating extra redundancy, and the case study of an operational ferry, the challenges and achievements. So the eFerry project is an EU-funded innovation project, and it's set out to design, construct, and demonstrate a 100% electric ferry. This ferry has been operating normally in the southern part of Denmark for almost a year now, and it's going well. And what makes this specific electric ferry remarkable is its range. It can travel 7 times longer between charges than any other ferry in the world, which is a prerequisite for an all-electric revolution, which is what we're discussing today. In fact, with this range, it opens up for more than 900 routes to be electrified in Europe alone. So I would like to explain to you how this long range is possible. And I won't be able to go through all the reasons, but I'll highlight two, and I will start at shore with the charging connection. So as you see on the picture, that is our charging plug, and it has a peak charging capacity of 4.4 megawatt. This makes it possible for us to have short port stays of only 20 to 40 minutes for each return trip. It also allows us to limit the number of charging stations to one, so only in one harbor we're charging. This is a fully electric ferry, so we don't have any diesel backup or any diesel generators. We have backup in the form of batteries. And as you can see from the general arrangements drawing on the slide, we've divided the batteries into two separate rooms in order to ensure redundancy. Each room is connected to its own electric drivetrain. So if one room against all odds should set out, we can still continue operating with the other room. Moreover, each room is divided into 10 separate strings, so you could call it double redundancy in that regard. Obviously, such an innovative and big project has not come without challenges. The largest challenge while we were constructing and going through the approval process was the missing standards. Due to no requirements specifically minded at electric operation, it was a quite time-consuming and challenging process. But luckily, we were collaborating closely with authorities throughout the process, and we still are. So hopefully these requirements will be adapted in the near future. Another challenge is the interfaces between systems, a more technical challenge. Of course, when you have different suppliers of different parts of the systems, there will be some interface issues that you have to be aware of, but you can work your way out of it, we have experienced. The achievements are plentiful. Obviously, emissions are reduced since it's a zero-emission ferry. And also operational costs are reduced due to lower expenses for fuel and manning and maintenance. And then we have succeeded in building a ferry with top safety for passengers and crew members, and also a reliable ferry connection on equal terms as a conventional diesel ferry. So that was all I had time for in my presentation, but I would like to invite you to address the discussion points that I mentioned in the beginning of my presentation in the following Q&A session. And I would also be happy to elaborate on gaining a return on investment. Thank you very much for listening.
Thank you very much indeed, Cecily. Great presentation. Ladies and gentlemen, I would urge you to take Cecily up on her offer and fire questions through the messenger. We'll get through as many of them as we possibly can. At this juncture, I'd like to invite Ferhat, when he's ready, to share his presentation. Ferhat, in your own time, the floor is yours. Over to you, sir.
Good morning and welcome all. Today I'm going to present our latest project, ZTAG project, means that zero emission electric tugboat. ZTAG has developed by our company, Navtec, Naval Technologies Incorporation, more than 40 years of experience, knowledge, and engineering in shipping business. So what is ZTAG? ZTAG is totally battery-powered harbor tugboat, first in the world, no emission and no diesel on board and so on. So it is like a prototype. It's now completed and now running in Istanbul, Tuzla Bay, in operating by the GİSAŞ company. And this is very simple, in fact, rechargeable technology, and we have redundant battery groups, two retardant system, totally retardant power system, in somehow if something happened to one battery room, the other can support all the vessel. And she is using lithium-ion batteries by Corvus Energy, according to us, the best in the shipping market, and approximately 1,450 kilowatt hours capacity for 1 day's operation. It is very important because according to the operational characteristics of this kind of 30 tons bullet pool harbor tugboat, 1 day's operation can be handled by this capacity. Of course, if you use the tugboat more dense than usual statistically, you need to recharge the vessel, but this is also easier because recharging is around 1 hour only. The advantages very, how to say, basically like this. This is totally eco-friendly because no emission at all, no diesel oil, no lubricating oil, no exhaust gas at all. So 100 eco-friendly project. And the most important thing is that operational costs 85% approximately less than a normal conventional diesel similar one. And also with this electric motor propulsion system, she is very active, and she is very easy to maneuver, very quickly responding to the demands, and faster reactions. So she is better than diesel ones. And the important thing is for ZTAC projects, because ZTAC is not only the one we have built already, but is a scale of harbor tugboats from 5 tons bullet pool to 75 tons bullet pool. We need to get first the information, operational characteristics of the subject project, and how often the tugs operate, how long an operation takes, distances to be sailed, power requirements, and so on. After all these data analyzed, we can prepare the power system of the tugboat, and then she will be very efficiently ready to run. While doing this, we are also using our STEMS software. STEMS software is Smart Tug Energy Management System, developed by Navtec again. This software is very important because this is developed for not only for one tugboat, but for a fleet of tugboats. So you can check all the online data of sea state, weather condition, battery position, charging stations, occupation, and so on, and preparing recommendations to the captain and the management company. Work orders you can go through with this energy management system, and the system is very smart. So learning about the even the weather conditions according to the date and so on. So recommendations are always better than one day before. And also, according to the system, we have developed a quick charge station. Normally, in 2 different ways, you can charge the vessel. You can charge through shore connection, normal port connection, 3-phase, which takes approximately 12 hours, something like that. But if you use the quick charging station, it takes only 1 hour to fully charge the vessel, which is again developed by Navtec. While we're doing this project, we have, of course, very important solution partners. First of all, BMA Technologies from Turkey. They have developed all the power system, electronics, and automation software and hardware, and also the workmanship of the electrical part of the vessel. And batteries from Corvus Energy, and also converter inverter systems and the drivers, motor drivers from ABB company. So as we have developed, design and built this one, you can see here the main particulars of the vessel, which are I should mention that smaller than a regular 30 tons bulletproof tugboat, which is another challenge. She is approximately 10-15% smaller in size, so she can go very narrow spaces in the shipyard or port facilities. And this is the end of my presentation. Thank you. First, lastly, I should say that this is ZTUG, I mean zero emission tugboat, and this is the beginning of an era. I believe that from now on, more and more ships will be fully electrical, I mean zero emission type vessels. Thank you.
We now come over to Halvard. Halvard, good sir, the floor is yours.
Thank you. Thanks for letting me join this webinar. Ladies and gentlemen, the all-electric revolution is all around us. We talk about optimization, emission savings, clean technology, and green solution. In this presentation, I will explain the efficiency gain and savings by going all-electric, and also talk about the things you need to consider to gain the return of investment for a non-electric vessel. First of all, I would like to explain to you the loss in various systems. If you put in a diesel system into a vessel, you will be, if you're lucky, maximum 40% out on the propeller. This means that there is a roughly 60% loss in the system. If you compare that to an all-electric installation, you will get roughly 90% out on the propeller and only 10% loss. So this is an important matter to consider. We at Corvus, we have roughly 300 vessels altogether with hybrid and all electric, but we have roughly a big number of all electric installation. You can see that we have 29 all electric ferries. We have ferries in Norway, we have ferries in Sweden, we have in Finland, and we have various places around the world with all electric. And this is coming more and more, of course. But we also have all electric tourist and passenger vessels, and they are also gaining momentum. And we have all workboats and aquaculture, fish farm kind of vessels. And then we have the star of this show, which is the ZTUG. And we also have several applications for operating ROV underwater application. So what you need to consider for a good return of investment, there are several things that you need. But first of all, you need to look at the operational profile. This is super critical to ensure that the next thing you need to then select is what battery technology do you need for that application. There is batteries with low weight, with high sea rate, with low sea rate, with volume, good volume density, and you need to select the right one. At Corvus, we had only 1.5 years ago, we had one type of battery. Now we have 7. Then you need to consider the safety. It's paramount that the vessel is safe, and this is safety on a complete system, not only on the battery. You need to look at the infrastructure, like Ara presented, and Ferhat for the ZTUG. You need to ensure that you can get the power on board and how long you have. Some applications have batteries on shore, and some can charge directly from the grid. But if you put in a good battery, you also need to plan the system very well and do the integration. Like Cecily said, integration is super important to make this complete system work. But after you got the system working and everything, you really need to put focus on training. I think training has been neglected for quite some time, and you need to train all the crew because on a vessel you have several crew. And when you change crew, you also want them to be trained. And there is a lot of funding opportunities around. Ara Ferry, they got money from EU, and in Norway there's a lot of funding opportunities from Enova and the NOx fund. So that is something you also need to consider. But you also have to make sure that the battery lasts for full design life. Normal design life is roughly 10 years. And we at Corvus, we have a portal where the ship owner can log in and then see how they have been operating, so they can compare the real operational profile with the theoretical operational profile that we started with. So if you ensure that all these bubbles are covered, you will get a very good return of investment. Here are some case studies that I would like to share with you. The one on the left is the Ampere, the famous mother of all electric car ferries. She has a 60% reduction in operational expenses. She saves 1 million liter of fuel per year, and that corresponds to 2,640 tons of CO2 and 15 ton NOx per year. This vessel have now sailed 4.5 years, and in 6 months it's halfway through the design life, and that corresponds to about 8 times the distance round equator only on our batteries charged by hydropower. Then we got a new type of vessels coming in, which is tourist vessels. We have now 2 called Brim and Bard. They are whale watching vessels. They use our lightweight battery Dolphin Energy, and they save around 80 liters of fuel per year, and that corresponds to 200 tons of CO2. And for this vessel, it is a license to operate. They don't think that they can in the future sail with a diesel and get close to the mammals that they are looking to show to their customers. And then we have the star of today, where we will save the Sea Tug, that we will save 76 tons of fuel and 200 tons CO2, and that Ferhat just presented. So back to what we call the zero emission evolution, is that we used to have the battery you see on the left, the 806500 is the one we used on the Ampere, and then about 4 years ago we got a new battery called the Orca Energy, and that saved the footprint and the volume by 50% and the weight by 30%. Then roughly 1 year ago at North Shipping, we came with a new battery called the Corvus Blue Whale, and that again saved the footprint and the volume by 50% and weight by further 30%. So the pace of ESS development is moving faster than ever. And then looking into the crystal ball, there will come new all-electric vessels very soon. The first type will be fast ferries. And what is important with fast ferry is that the batteries are extremely lightweight applications. And the next type of vessel we think will come is kind of bunkering vessels. Like this vessel here in Japan, she will stay 7-8 hours alongside another vessel to bunker her. And then you need a battery with a very low sea rate. And then we also think that RoPax and ro-ro type of vessel or any ferry will be able to move up to several hours of operation on battery only. And then you also need a low sea rate type of battery. So to wrap up this presentation, I have a few things that you to consider. Is how you can plan for flexibility in operation, and how you can make sure your design of vessel, you design a vessel so that you can get the next technology of batteries on board when it's ready. That was all for me for now. Thank you, and over to you, Edwin.
Thank you very much indeed. Testament to a job well done by all 3 panelists is the volume of questions that we've received. Please do keep them coming, because as you know, we will try and take as many as we can in the time available, and any that we don't, we come back to you in writing. Cecilia, I know that you have a comment or two regarding training, so perhaps I can invite you in the first instance to share that.
Yes, thank you very much for that. I really enjoyed the 2 other presentations, and I'm happy to see that we agree on the challenges and the opportunities in this field. And I was especially excited about your comment about training, Halvard, because we've also had a big focus on that. So I'll just start out by explaining how we have approached this. It wasn't part of the plan initially, but it became obvious very soon that we needed to do some training for all crew members, and I agree it should be everybody on board, regardless of function. And they have responded very positively to it, and the concerns and to some extent anxiety about being on a fully electric ferry and this new unknown technology has been calmed down by these courses. And moreover, we've also used the courses to educate ship owners and crew members from diesel ships that might be interested in electric operation. And it has helped breaking down some of the barriers that you naturally have. It's a bigger investment. Can that actually pay off? And is it safe? And how does it work? And which considerations, like your circle with all the bubbles around. And we've had very positive responses to that. So I hope that that can be part of the action you can take to an all-electric revolution. So I was also interested in hearing about how you have approached training and what actions you're taking to break down the insecurities and barriers.
Thank you. Perhaps first Halvard and then Ferhat on the subject of training. Come in, Halvard.
Yeah, so we have several courses, training courses that we are offering. We have from everything from basic ESS training up to maintenance and commissioning, and then for troubleshooting. And so we can train the crew and the integrators to ensure that they know what it's the battery, how it's built up, how the battery management system is working. And we are also offering training for firefighters and other people that needs training on batteries, because we saw from the incident we had in Norway last year that both the crew and the firefighters, they need to know what they have. Everybody's used to a diesel engine and people know how to do that, but there is a lot of parties need to be trained on a battery operated vessel.
So this is one of the polls we've got lined up for you, ladies and gents. It will appear on your screen momentarily. The question is, what's the greatest barrier to the all-electric revolution? You'll see there are a range of options there: technology, safety, economics, and behavior. I know you cannot see the results. I can, and I do share them in an article after the webinar, but what I can tell you is that around 63% are saying economics. I can tell you 17% are saying technology, 13% are saying behavior, and 7% are saying safety, but that is a movable feast, and I promise to share the final results in an article after the webinar. What I will do now is put a second poll to you before we come to that deluge of questions you've put our way. Do you believe that within 5 years there will be a fully mature hybrid and electric industry? Once again, a range of options. Do you believe yes, there will be within 5 years, or variously 5 to 10 years, 10 to 20 years, 20 years plus, or it will never happen? Just 10 seconds more on that. What I can tell you is that approximately half believe it will take 5 to 10 years. Gratifying for our panelists, no one is saying it will never happen or it will take 20 years, so rest easy there. About 18% 10 to 20 years, 25% think that 5 years is about right. Full results in an article after the webinar. Right, I promised that I would come to the many questions. So the next one is as follows: how to achieve the operational cost reduction. We've variously spoken about that, since the fuel cell is so expensive and H2 is also not cheap. Perhaps this is one for Halvard. Halvard, do come in.
Yeah, can you repeat the question?
With pleasure. The question is, how do you achieve operational cost reductions, especially since a fuel cell is so expensive and hydrogen is not cheap?
Yeah, my presentation is mainly on the battery side. So for that, it is important to make sure that you select the right battery for your application. And if we are going to go into fuel cell, I think it's important for a fuel cell to work together with a battery because they are a perfect match. But I think the operational profile and selection of the right battery is the way to go.
Okay, thank you. Welcome back, Ferhat. I don't know whether you can speak to this question. Here it is, so do come in. How do you achieve operational cost reductions since a fuel cell is expensive and hydrogen is not cheap? Any views on that one?
About the OPEX, I mean, operational costs, this is what we have done is ZTAC is a tugboat. So our calculations based on tugboat operations. So as we have in hand for even 5 very similar diesel-driven ones, we have statistically studied on it just before the project realized. And then as I presented, 85% OPEX savings. It is amazing. And right now, almost 1 month, during the last 1 month, the ZTAC 30 is in charge, and we are verifying this figure, which is very, very impressive. Almost only electric bills, which is also having some subsidies from the government. And this will be more subsidies. There will be more subsidies, I believe that. So about the hydrogen cells, we are continuing studying on it. Right now, I'm not able to compare them, but about diesel or hybrid ones, right now, ZTAC project for the tugboats, of course, because I'm experienced on them, is an amazing operational cost savings, which I am not talking about the crew, because the crew ratings and the numbers will be changed as well, but right now the regulations are just having some limits.
Thank you. Let's turn our attention to the e-ferry concept. How does sea state affect sailing? And if you have rough seas, would this ever give you limitations on whether or not you can sail based on available battery power? With diesel electric, of course, you just burn more fuel and make the engines work harder. You're smiling with recognition, I think, there. So come in, Cecilia, please.
Yes, sure. That is a concern that you have to be very aware of when you're only sailing with batteries. And that's also the reason why we have had to make this double redundancy concept with separate rooms and separate strings so that we always have a backup. And obviously, that makes training very important for the navigators, since they have to start out the day looking at the weather conditions and the stream to make sure that they plan the day in a proper manner. That being said, there are certain limitations on the battery pack where you will get an alarm if you're under a certain percentage on the batteries. So therefore, they will never be allowed to sail out if there is any risk for them not to get back. And with regards to weather, the data collection phase that we've been through the last year has shown that actually when you have rough weather out, you have nicer weather home. Obviously, you have the wind against the ferry on the way, one of the ways, and then the wind will help you on the way home. So actually, all in all, they rarely use more than the average amount of kilowatt hours, even in rough weather. And Edwin, can I just comment on the previous question? Do we have time for that?
With pleasure. Yes, of course.
So I would just like to say that obviously you have a different business case when you're working with battery electric ships. It is more expensive, and I'm not so familiar with the fuel cell technology, but I assume that it's the same logic that goes for that investment. You have to look further out in the future. You can't just look at what you're investing here and now. You need to look at the lifetime of the vessel, which is usually 30 or 40 years. So you have a lot of years to earn back that initial investment. And in our pre-study, before we started operating the e-ferry, the assumption was that we would actually have a return on investment within 10 years. Now we have collected data from the actual operation of the ferry, and I can't reveal the exact number of years that we expect to have a return on investment, since it will be published on the 3rd, but it's well below 10 years. So it looks really promising, and you have to remember that you'll just have savings for the rest of the lifetime of the ferry. So it is a good business case.
Thank you.
Regards.
Go ahead.
Yeah.
Ever so briefly, we've got a lot to get through, but
yes,
please go ahead.
I just wanted to say that the data collection is actually being published on the 3rd, and you're welcome to contact me. Then I will send you all the data on the 3rd. That was all.
Wonderful. Next question is regarding maintenance and overhaul of battery-run ferries. How frequently would the battery need to be changed, and what are some of the challenges faced during the process? Anyone like to have a go at that one? Okay, Cecile, kick us off. I've got questions for the other two as well. Over to you, Cecile.
Yeah, I'm sure that Halvard will also be happy to answer that, but I just wanted to say that in our case, we expect that it's within 8 to 10 years, but it depends on how you use the batteries and which type you have. And the development within the battery technology is so fast that that you actually can have different expectations within the near future. And a thing that you have to remember when you invest in a battery pack and have to change it during the lifetime of the vessel is that it's becoming more and more normal to work with second life on shore, where you can have a battery bank on shore. So in that way, you will actually have an even better business case with regards to the battery change.
Thank you. Halvard then Fairhat, please. Halvard, come in.
Yeah, no, I fully agree with Cecily there, and the normal operation and design life is 10 years, and that means that during these 10 years there is very little that you need to do. You need to make sure you have the software updated and that you are in a good shape, and that the state of health is developing according to the design life, so that you are controlled, that you have enough energy on board. And state of health is that measure. We are also looking at the second life, because all electric vessel have a certain operational profile. When it's finished with that operational profile, there is maybe 60 to 70% left of the battery, and that can be utilized in a second life, and we are offering that at Corvus, to take back batteries and offering them to other application as a second life.
Thank you. Fairhat, please come in.
Yeah, it is very clear. The same, battery manufacturer as we're using with Cecily. So 10 years for our ZTAC as well, but it is very interesting and very efficient. Why? Because at the 10th year, as Halvard said just before, it doesn't mean that your batteries are totally off, but in our case, it is around 87% of the batteries will be in hand at the 10th year. And of course, the operator can continue even with a little less efficiency, or exchange them into the newer technology batteries and so on. But during this 10 years of lifetime, let's say, maintenance is, okay, jokingly, I can say that it is online. Because if the stamps, which the software I'm talking about, SmartTAC Energy Management System, is on, it is connected to Corvus and my design engineering company. So the online software, updates and so on is continuing. So the main maintenance is continuing on that. And the others is almost nothing for the workmanship. So for the 10-year lifetime, the battery groups are always in the highest efficiency. The lifetime and the battery life is the most crucial questions by the operators or the ship owners, but I believe that this is, in fact, this is already solved.
Thank you. Another couple of questions to follow up on that, Ferhat. But ladies and gentlemen, such has been the volume of questions we've received that I'm going to extend matters by 10 minutes. So I hope you have no other plans, because really I want to get through as much as we can. So Ferhat, two for you. And the first one is for ZTUG. When using battery power, do you get an added advantage in terms of rapid changes, demands, or surges required in torque, where electric can respond better to traditional engine types?
Yeah, Edwin, it is absolutely, the answer is yes, because during the research and development period, we were assuming a better, how to say, efficiency on maneuverability and so on. But right now we have verified on field, because the tugboat is moreover than 1 month running, and tugging operations, all the things are done. So first thing is the reaction time. The reaction time is excellent, comparing with the diesel ones, because when you paddle, it is paddling. I mean, when you need full power is under your hand always, because this is an electrical system, and electrical motors limited only by your mechanical systems, reduction gear and so on. So also, all kind of power up and power downs are more efficient than diesel ones. And this is, of course, this is our design, but this is not our opinion, but the captain's opinion so far, because they have now operating it. They're very happy. And also we are now developing through, again, this STEM's smart software, the behaviors of the captains through the, how to say, power system of the tugboat. And if need, we are changing, we are developing our software, power software as well.
Thank you. A further question for you, Ferhat, then Halvard. I've got one for you, so stand by. Ferhat, could you say something around transit speed for the ZTUG and how long it can operate between charges, and what dockyard infrastructure you need to supply suitable charging points?
Okay, I mean, on this ZTAC 30, which is a project and being done, completed now, 22 miles approximately endurance we have. I mean, it means that approximately 2.1 hours full speed is okay with the one charge. But of course, this one charge means a DOD and so on, related to some other, how to say, variables. So it means that you can go 11 miles and come back with full speed with one charge, and then you need to you have, and then after you have only some emergency power on your batteries, and you need to recharge the batteries. Charging period is less than 1 hour with our quick charging station, but also total three different ways to charge ZTAG. One is this quick charging, which means that you come up and 1 hour fully charge. Or if you come 50%, it takes only 20 minutes. Also, normal shore connection system can charge the batteries, which takes 11 hours or 12 hours, as I can remember that. And the third, specifically for this boat, we have a small fire diesel motor on that. It is integrated with the generator. She can also charge herself with this device as well. If somebody thinks about redundancy, the third redundancy, we can put a small generator on board to make an emergency charging and so on. But by the way, I have to say this thing. This is very important for us. For one full charge is enough to operate this tugboat for 1 day, statistically, because we have started from that point to create this tugboat. I mean that if it is 100% charged, normally 1 day's operation is okay with this charge. You don't need to recharge in between the operations. But of course, statistically, if you force the tugboat more, you need some intermediary chargings as well.
Thank you. Appreciate it. Halvard, a couple of questions for you. Ladies and gentlemen, keep the questions coming. This is the beauty of joining us live. As you know, anything we don't get to, you get a response in writing, so there's every reason to fire them in. Halvard, the first of the two questions, you did mention safety is an important consideration for return on investment. Do various battery packages solutions for ships have varying safety? And if so, what is the trade-off for lower safety? Big question. Over to you, Halvard.
Yeah, there is different type of safety within the maritime ESS solution, and also the way that some are putting an industry battery into a marinized system, and they get a different safety level. But the highest safety level is a single cell passive thermal runaway isolation with an exhaust system built into your vessel. That is the highest today safety system, but not all battery system do that, because the class and the flag allow a full module to go into thermal runaway. But we at Corvus, we believe that the single cell passive thermal runaway isolation is the way to go.
Thank you. Now, we've had a lot of reference to battery life, Halvard, 10 years, 8 years, etc. has been mentioned. Is there any deterioration of capacity over the lifetime of a battery, especially towards the end of life? The presumption, of course, is that replacement can be done by bank rather than full tug after 10 years. And in addition, what are the green recycling or reuse options for your batteries? Hopefully they're not just thrown in the landfill.
No, for sure not. Now, what is happening is that the battery system have two types of degradation. So what Farhat said is that at the end of their 10 years, they have something about 85% state of health left. But there is a degradation on battery for only what we call calendar aging. That means that they are degraded without even being used. So if you buy a battery and just store it on the vessel, it will also degrade. But also the operational profile. These two things together will take battery life out of the system. And that is why we calculate at for a 10-year between 60 and 70 or 80% state of health at the end of life. When it comes to the end of life and you take it out of all electric ferry, there are several other places you can use the battery. You could use the battery on the same ferry, but on the shore side to charge the ferry if the grid infrastructure isn't sufficient enough to ensure that the sailing, that the charging can be done. There is fish farm industry in Norway and many places where you can utilize this, and it can be utilized on any other application. The good thing about the maritime batteries is that the safety is much better than the land-based type of battery. So there is an enormous amount of application where you can use the battery for a second life. And after the second life, there is a possibility to recycle the batteries. We have done that on several occasions, and for the battery that Farhat has on a sea tug, it is 99% recyclable on the weight. That means you can take out all the cobalt and all the material from the system, and you can recycle it and then reuse it.
Would fast charging reduce battery life, and if so, by how much?
Fast charging is more the C rate. If you need fast charging, you need to have a high C rate battery, and C rate is the measure on how fast you can charge and discharge the battery. But for all this typical ampere and others, they fast charge every 20 minutes, and that is no problem for the battery, as long as you have selected the battery suitable for the operational profile.
Thank you. Ladies and gentlemen, I have to be conscious of time. So in a moment, I'm going to come to each of our panelists in turn, in the order that they presented, to share their key takeaways and conclusions. While I give them a moment to collect their thoughts, one more poll for you, ladies and gentlemen. It's very much of the time. How has COVID-19 impacted your decision to invest in the all-electric revolution? Once again, you've got a multitude of options there. You might feel it hasn't. You might feel it's put it back a year, 2 years, 5 years, or indeed it's mothballed any movement in this direction for an indeterminate period. Well, what will give comfort certainly to the supplier on our panel is that 56% say it hasn't, about 19% are currently saying a year, 13% are saying 2 years, 8% 5 years plus, and just 4% have said that they have mothballed for an indeterminate period. Full results in an article after the webinar. So, ladies and gentlemen, at this juncture, I now come to each of our panelists in turn, starting with Cecily, coming to Ferhat, and concluding with Halvard for their key findings and takeaway. I remind you, ladies and gentlemen, that we do share answers to all of the questions afterwards within a week. But now it's time to hear from Cecily. Over to you, Cecily.
Thank you. And thanks for an interesting day. So based on the multitude of questions and the responses to the polls and also the presentations from my co-panelists, I'm sure that we can actually make an all-electric revolution happen, but we need to give out information as much as we can in order to break down potential barriers based on misunderstandings or old, outdated information. So I'd just like to remind you again to contact me if you're interested in the data analysis and evaluation of the first year of operation of the e-ferry. Thank you.
Thank you. Ferhat, good sir, the floor is yours.
Yeah, thank you. First of all, everyone who joined this webinar, I can understand that the questions are very, very, how to say, forwarding us. So I would like to say this is a revolution, this begun, and in the near future, not far future, we will see more and more full electrical ships on the sea. So as Cecily said, that we are ready to clarify all the suspicious technical matters. As Navtech, as we are an engineering company, we are, how to say, this is our job anyway. But I believe that in soon, very much powerful full electrical ships will be sailing on the oceans. Thank you for everything.
Thank you, Ferhat. Halvard, the floor is yours.
Thank you very much for listening to us on this webinar. And as you see, the all-electric revolution is coming to more and more vessel types as we speak. And what is important is to ensure that you have the right type of battery for your all-electric application. So if you only remember one thing from my presentation, that there is no one size fits all when it comes to battery.
Thank you very much indeed, Cecily, Ferhat, Halvard, for what has been a truly stimulating and inspiring webinar. Ladies and gentlemen, part of your dividend, of course, is that you will receive the presentations and you will receive answers to all of the questions in writing after the webinar. So thank you for joining us. Let me share with you what's next. We are looking at the business case for hybrid and electro technology. That's tomorrow. That's at 1:30 British Summer Time. And that again is for 45 minutes, unless we get a surfeit of questions, of course, and then we'll add a little bit of extra time. Next week, we have an entirely new webinar week, which is offshore wind. Should you be interested in the ever-evolving Riviera webinar program, please do visit the dedicated website, rivieramm.com/webinars. What will continue to happen, of course, is that Riviera will serve the information that matters to you most. We will do this in a number of ways, through our weekly newsletters, through our magazines, through curated content online that matches your interest, and relevant events such as this. In order to ensure you don't miss, which is the key thing, please register online on our website. You'll see there's a blue bar at the top right-hand corner of our homepage. Honestly, it takes half a minute, and by investing that half a minute, you ensure you don't miss out. So please do take the full opportunity. More than enough from me, safe to say thank you very much indeed to our panelists. A huge thank you to Navtech Naval Technologies Inc. for generously supporting today's webinar. Ladies and gentlemen, thank you for coming from near and far. Time dictates that we are at the end. Please do complete the exit survey. I will email it to you in order that you can complete it and receive the presentations in turn. I look forward to seeing you tomorrow, where we look at the business case. And for now, from me and all the panelists, wherever you happen to be in the world, please stay safe, stay well. Good morning, good afternoon, good evening, and goodbye.